Today's topic is tangent lines, or first derivatives, second derivatives, graphs of derivatives. So the figure above shows the graph of f prime, the derivative of a twice differentiable function f on the interval -3 to 4. And notice that they're including -3 and 4. The graph of f prime has horizontal tangents at -1, 1, and 3, and kind of showing you that those are the mins and the maxes of the graph. The areas of the regions bounded by the x-axis in the graph of f prime on the intervals -2 to 1 and 1 to 4 are 9 and 12 respectively. A, find all coordinates at which f has a relative maximum. Give a reason for your answer. So there's a relative maximum on -2 because the derivative, f prime, is changing from positive to negative, and that's what we have right here. F has a relative max at x equals -2. How do we know that? F prime changes from positive to negative at x equals -2. B, on what open intervals contained in -3 to 4 is the graph of f both concave down and decreasing, and give a reason for your answer. So we're looking for, let's see, concave down, that's where f prime is decreasing, and the function is decreasing where f prime is less than 0. So we want to know where f prime is less than 0 and where f prime is decreasing. Well, that's from -2 to -1. F prime is decreasing and negative. And then from 1 to 3, f prime is decreasing and negative. And that's what we have for an answer, -2 to -1 and 1 to 3. F prime is negative and decreasing. Now this suggests that the second derivative is less than 0, but we don't have information about the second derivative. We have information about the first derivative. C, find the x-coordinates at all points of inflection for the graph of f. Give a reason for your answer. So at -1, 1, and 3, the second derivative is changing signs, but again, we don't have information about the second derivative. We have information about the first derivative. So the first derivative goes from decreasing to increasing, then increasing to decreasing, and then decreasing to increasing. And that's what we've suggested in the answer here. So the points of inflection are at -1, 1, and 3. F prime changes from increasing, decreasing, or decreasing to increasing. D, given that f of 1 is 3, there's the initial value, write an expression for f of x that involves an integral. And then we'll find f of 4 and f of -2. So the expression is here. F of x is 3, and then we start at 1 to x of f prime of t would give you f of, well, whatever x value you want. And typically, if we have x up here, these variables are different. We usually use t's for that. Now f of 4 starts out with 3, and then we're going from 1 to 4. So from 1 to 4 has an area of actually -12. So we have 3 minus 12 is -9. And then from 1 to -2 is going backwards. So that -9 becomes a +9, and we get an answer of 12. Here's the rubric. You can see the points for each of those. The function g is defined for x greater than 0 with g of 1 equal to 2. G prime is equal to sine of x plus 1 over x, and there we have the second derivative of g. Find all values of x on the interval 0.12 to 1, at which the graph of g has a horizontal tangent line. So one point is saying, well, now we're looking for where the first derivative is 0. So I have the equations in y1 and y2. And the window, I went from 0.1 to 1, and then -3 to 10, mainly, I think, for the second graph, the g double prime. So let's graph this one. Let's graph the first derivative, and there it is. And we see 2 zeros. So actually, I see we should probably go for this one, window. Let's go from 0.12. Let's do that. There, now we have 1 0. I knew, or 2 zeros. I knew there wasn't 3. So then you calculate the 0, calculate a 0, and then you would go all the way over to this left one, which is at 0.163. How about 0.16 to 0.164? There we go. There's the, no. Let's try that again. Back up here. Let's go here. Oh, I had to guess. I wasn't done yet. That's what it was. 0.163. And then the other one to the right is 0.359. B, on what subintervals of 0.12 to 1, if any, is the graph of G concave down? Well, now we're looking at the second derivative. And I put that into y2. So I'll turn that one off, turn that one back on. And for this one, I wanted to go from 0.1 and graph it. So you can see there's two zeros right away, and then the graph is below the x-axis in between those two zeros. So we're going to go calculate a 0, and we're going to go all the way. What if we did 0.1? And then there it is. I just saw it flash by. There it is. Here, and then back up. Now we just got to make sure that this answer is past 0.12, because I did go from 0.1. And so we're going from 0.129, and then the 0 after that is 0.222. That's the interval. How do we know it's concave down? Because the second derivative is less than 0. C, write an equation for the line tangent to the graph of G at x equals 0.3. So we need a point, and we don't have this. We don't have that yet. And we have, do we have that? All I got to do is I got to plug 0.3 into the first derivative. So if I go back here, turn this back on, turn this off, and go calculate a value, I can do it right on the graph here. And we're going to calculate 0.3. And that's where I got negative 0.472. But now we need the y coordinate. And the y coordinate, g of 0.3, is going to be 2 plus, I go from 1 to 0.3, because that's this initial value right here that we're using. So starting at 1, the value is 2. So there's the 2 starting at 1. 1 to 0.3 of g prime of x. So we can go math, actually, let's go 2 plus math number 9. And we're going from, what is it? Is it 1? Yeah. 1 to 0.3. And I already have the equation. I already have the first derivative in y1. So we go variables, y variables, function, y1. And we can go over to here, x. So the y coordinate is 1.546. And then we can just write the equation of the tangent line. Does the line tangent to the graph of G at x equal 0.3 lie above or below the graph of G for 0.3 to 1? Well, if we plug in, we know that the second derivative after 0.3, if we look at, let's go back to this one, the second derivative. And we graph this. After 0.3, the second derivative is positive, which means that the second derivative is positive on 0.3 to 1. Now, if the second derivative is positive, that means the curve is concave down, and the tangent line will lie above the line, or excuse me, above the curve, no matter where the tangent line happens to be. So the line lies above the graph. Why? Well, why is because the second derivative is greater than 0, which means that the curve is actually concave down. Here's the rubric. And let's go through this, I suppose. The tangent line to a point and the normal line to the same point are perpendicular. So tangent and normal lines are perpendicular to each other, which means their slopes are opposite reciprocals. Let's do this partial fraction one. Well, let's factor this, I guess. 2x and x. And then we have minus 3 here and plus 1. So 7 over 2x squared minus 5x minus 3 is equal to something over 2x plus 1 plus something over x minus 3. So 7 is equal to a times x minus 3 plus b times 2x plus 1. So we're going to let x equal 3. So 7 is equal to 7b. So b is equal to 1. And then if we let x equal negative 1/2, we have 7 is equal to a times negative 7/2. So a is negative 2, negative 2. Well, now this is the integral of, let's do the positive one first. 1 over x minus 3 minus 2 over 2x plus 1 dx. Now there's a very specific reason why I would have one of the factors to be 2x plus 1. When we take the antiderivative, that's the natural log absolute value of x minus 3, but then minus natural log absolute value of 2x plus 1 plus c. Now the question is, well, where did the 2 go? Where did this 2 go? Well, you would get the 2 if you took the derivative of the inside of that natural log. So we can't have, if we had a 2 here, then the derivative would end up being 4. All right, well, a possible answer on the multiple choice could be this as well, over 2x plus 1 plus c. There we go. Pause it if you need to write all that down. Chain rule. Well, I don't have the instructions, but it would be fine. Let's find y prime. That way we have to use the chain rule to do this. So it's product rule with chain rule. And this one's really long. So I'm going to start way over here. Y prime is equal to first times the derivative of the second plus the second times the derivative of the first, which is 3 sine squared of x times cosine of x. And there's really not a whole lot to clean up. You could put the constants out front if you want. So this could be a possibility for like a multiple choice answer. Maybe 3, maybe sine squared, cosine, and maybe tangent, something like that.